Hello everyone, good evening and welcome to my channel Aptitude Club. Today in this video we are going to discuss a very important question from the concept of proportionality from time speed distance chapter. Now these kind of questions have been asked in the previous CAT exams a lot of times, and I feel it's a very important question when you are learning the topic TSD. Okay, beautifully the concept of a change in speed and how does it affect time has been integrated in this question, and a must solve question for all CAD aspirants if you really want to take a good hold of the topic time, speed and distance. Okay, so we'll be discussing in detail what should be the approach and how we should formulate a thinking process for such kind of questions. Before we begin, as always, I'll ask people who are watching this video to pause at this moment, try this question yourself first and then look at the explanation. All right, so let's begin. Now, in my experience of solving questions, what I've seen is whenever you are solving a TSD question, to put it in the form of a diagram, visually, if I can understand what are the given constants and what all things have been given, what is it that the question asks us to calculate, if we can put it visually, then it becomes very easier for us to calculate and understand the approach going forward. So every TSD question when we are solving, most of the times it involves a diagram. So very clearly, neatly and precisely we should be able to put whatever information has been given in the form of a diagram. If you can do that, the solving really becomes very easy. Okay, so let's try and put the information given in the form of a diagram. It is saying that a car, after traveling 18 kilometers from point A, developed some problem in the engine and its speed became 4/5 of its original speed. So the car was traveling from point A and it developed some problem after traveling 18 kilometers. So the speed reduced because of the problem. Now we know if speed is reducing, distance is speed into time. So if distance is constant, so I can say speed is inversely proportional to time. So if speed reduces, time has to increase. So if you travel at a lesser speed, you will take more time. Because the speed reduced, as a result, the car reached its destination point B 45 minutes late. Obviously, speed has come down, so the time will go up. Now, if the engine had developed the same problem after traveling 30 kilometers, so instead of 18 kilometers, had the problem occurred after 30 kilometers, that means extra 12 kilometers that car could have covered, and the problem would have occurred at 30 kilometers, then the car would reach 36 minutes late. So two type of scenarios have been given. So if we put it in a diagram, let us say this is my distance point AB. The car is traveling from point A and the destination is point B. And the car developed the problem at point C, which is 18 kilometers from A. This is given. Problem occurred. I'll assume a few things. Let S be the normal speed of the car. So when I am considering this distance CB, let this distance be D2, so which will be speed into time T2, where T2 is the usual time to cover distance D2 at normal speed S. So if there would have not been any problem and the car would have covered the total distance normally, the time taken is T2 for this distance D2. Now because of the problem, what happened is the speed of the car became 4/5, 4 by 5 times. D2 being constant, compare these two equations. Here I have D2, here also I have D2. LHS is same. RHS S into T2, here also I'll have S into T2. But I am multiplying a 4 by 5 to the speed because speed has reduced, became 4/5 of itself given in the question, 4/5 of his original speed. So I have to do something with time, or else this equation cannot be balanced, because D2 is S into T2. So if I am multiplying a 4 by 5 in S, I need to multiply its reciprocal here, only then it can be balanced. So S into T2 will be D2. That means this 5 by 4 into T2 is my new time. So what is the extra time? Time has increased, and what is the extra time? Now earlier the time was t2, now it is 5 by 4 t2. So 5 by 4 t2 minus t2, I can say the extra time is t2 by 4. t2 by 4 in the question is given as 45 minutes. The car reached its destination 45 minutes late. So I can write, okay, t2 is 180 minutes. 180 minutes is the normal time that the car would take traveling at its usual speed to cover this distance dB. This can be approached in another way, that I am writing d2 is equal to speed into time. So if speed has become 4/5 of itself, I can say the reduction in speed is 20%. If speed reduces by 20%, then time will increase by 25% due to proportionality. This concept is called as proportionality. I'll explain proportionality in some other video. If you don't know what proportionality is, there's this percentage table that we refer, and directly we can get that the increase in time will be 25%. If the decrease in speed is 20%, increase will be 25%. Now if at all you don't know this, I explained you the normal method also. 4 by 5 times speed means 5 by 4 times the time. So the extra time or the time increase is t2 by 4, which indeed is 25%. 1/4 of anything is 25%. So t2 by 4 becomes 45 minutes. So t2 is the normal time, that is 180 minutes. That means traveling at its usual speed, the car takes 180 minutes from point C to point B. This is my scenario 1. Scenario 1. Now if I'm looking at the second scenario, scenario 2, again I'll take the distance AB. This is point A and this is point B. This is point C, which is 18 kilometers from point A. And at point C, the initial accident or the problem occurred. I'll now reach a point D. And D is like 30 kilometers from the starting point. And this time the problem occurred here. So that means this gap is 12 kilometers now. Now again, I'll take, let us say, this distance. Let this be D2. Or let me take D2, I have already taken. So let me take it as D3. So let us say this distance is D3, which is S into T3, where T3 is the usual time to cover distance D3 at normal speed S. So if there would not have been any problem, the car would take time T3 to cover distance D3 at its normal speed S. Now because of the problem, again a similar situation will arise. Speed has become 4 by 5 times of itself. So using the same logic, time will become 5 by 4 times. So what is the extra time? Again, initial time was T3. Now the new time is 5 by 4 T3. So the extra time is 5 by 4 T3 minus T3, which is T3 by 4. This extra time is the time by which the car is late now. Now in the second scenario, the car was late by 36 minutes. So this is equal to 36 minutes. This gives me T3 is 144 minutes. This is my second result. So at its normal speed, the car takes 144 minutes to cover this distance dB. Now if I combine both these scenarios, scenario 1 and scenario 2, the diagram would look like this. There's the starting point A and the destination point B. There is this point C where the problem initially occurred, and there is this point D where the second scenario problem occurred. This distance is 18 kilometers. This distance is 12 kilometers. We don't know what this distance is, but time wise I know that to cover CB distance, the time taken is 180 minutes. We got it in scenario 1. And to cover DB distance, the time taken is 144 minutes. That means to cover this distance, time taken is like 180 minus 144, 36 minutes. Traveling at normal speed, traveling at speed s, time taken to cover the distance CD will be 36 minutes. Because this total time is 180, this is 144. So CD, that particular patch, will be 36 minutes. So what will be the normal speed S? Distance is 12 kilometer. Time is 36 minutes, which I can write it as 36 by 60 hours. So S is equal to 12 into 60 divided by 36. So 6266 and then 610. So I get S. The normal speed of the car is 20 kilometers per hour. So first part of the answer is done. This is the normal speed of the car. Then I need to calculate the distance. Now the distance AB, I can write it as AC plus CB. AC distance was given in the question as 18. So this I'll write as 18. This distance CB, C to B, the speed is 20 kilometers per hour. And the time taken to travel it is 180 minutes, which is 3 hours. So 18 plus 60. So total distance AB is 78 kilometers. I got the second part. Very easy. Standard process of solving, but we need to solve such questions and very carefully and minutely understand which part of the question you should focus on. Because this gap CD was given, we knew the distance. So if somehow we could find the time taken to cover that particular distance CD, we can get the normal speed. Once we get the normal speed, then we can get going. So two scenarios. Scenario 1 where the problem occurred after 18 kilometers. Scenario 2 where the problem occurred after 30 kilometers. So I got the time for that 12 kilometers patch, and then I got the normal speed and the total distance. So hope all of you understood this question. So my answer will be ideally none of these, because speed 28, so it cannot be option 1, cannot be option 2. Here the speed matches but not the distance. So I'll go with none of this. So speed is 20 kilometers per hour and the distance AB is 78 kilometers. This was a previous CAT question and I hope all of you understood this. Must solve question for all CAT aspirants. Very good question indeed. Try and solve more questions on similar lines from the concept of proportionality. I'll discuss what proportionality in detail in another video. Till then, if you have watched this video so far, I hope you liked the explanation. Do subscribe to my Aptitude Club channel and explore the previous videos that I've done on this. You will definitely find them useful on your CAT preparation journey. We'll meet again very soon on yet another video. Till then, keep solving, keep studying, and thanks for watching the video. Bye bye.